Hello there and welcome to today's lesson on ultrasound, which is for the P4 topic, radiation for life. Anyway, we'll start this one with a joke. Who's the coolest person at a hospital? It's the ultrasound guy. Anyway, I'll see you at the end. Okay, so let's have a look at our objectives for this lesson. So by the end of this lesson you should understand how ultrasound waves are used. That's both for medical and for industrial uses, and the transfer of energy in transverse and longitudinal waves. Okay, so with a wave, you may have been used to seeing a wave that has this particular shape in one of the previous topics. Now if we put a line through the middle there, right, let's move that up a bit, I think that's a bit low. Okay, so if we put that line up, now there are several things that we can show on here. Now the first one is where we can go from any point on here to here, and that will be our wavelength. Now we can also go from the top to the middle, or the middle to the bottom, and that will be our amplitude. Now as the wave is moving in this particular direction, the energy is being transferred from here over to here. Now this means that as the waves pass this position here, we get a frequency. So it's the number of waves that pass that point every second will be the frequency. Okay, so what we'll do is we'll look at transverse and longitudinal waves. Now if we start with a transverse wave, if I move the slinky spring up, now I'm moving it up from this end. Okay, now you can see that the energy is being passed along from this end over to this end, so we've got a direction of movement going this way. Now the individual springs are only going up and down, okay, so the energy is moving up and down, but it's passing it along in this direction. Whereas a longitudinal wave, instead of it going up and down, it goes backwards and forwards, backwards and forwards, backwards and forwards. Now in this you get areas where it all contracts up and areas where it expands. Okay, so it contracts and expands. Now between one area where it contracts and the next area where it contracts, that is the wavelength, as opposed to the way we saw it on the previous one. So as we saw with the slinky spring, we've got the direction of movement going in this way, and we've got the wavelength between the areas where it contracts, and then you've got the areas where it expands here. Now with the transverse wave, okay, you've got the wavelength as we saw between the areas of red here going up and down, and then you've got the direction of the movement going in that direction. Okay, so some of the main uses for ultrasounding are ultrasound images. Now these are where we can use the sound waves, which are high frequency, which is why it's known as ultrasound, where they are sent into a body and it can either create an image. Now this is what we use for a pregnancy scan, okay, so a prenatal scan. Now you can see here that we're sending a wave down and it will reflect back on the body tissue, and this way we can create an image on a screen that can show the actual baby. Now these are a lot safer to use than X-rays, because X-rays are more penetrating. They can damage living cells, whereas the ultrasound won't. Now we also get the image of the soft tissue as well, rather than just the bones. Now, other than ultrasound scanning, we can also use ultrasound to get rid of kidney stones. Now, because they are vibrations, you can send a sound wave into here and it will penetrate through the skin, and when it gets to the kidneys, it can hit the kidneys and it can cause the kidney stones to break, and then they can be easily removed through the urine, and you just wee them out. Now, this is obviously going to be a lot easier than slicing the person open and trying to get them out that way. Now, ultrasound can also be used when in rock sampling, so we can have a look at what the where the boundaries are in different types of rock. So if we look at this diagram here, you can see that ultrasound is passed at an angle, and then it reflects when it gets to the different boundaries of the different rock, and that can give you an indication of how deep it is, how certain layers go, and it can also help you when you're looking for fossil fuels as well. Now, it does this because it's a sound wave. We know the distance it's travelling, and we can work out, the speed it's travelling, so we can work out the distance that it travels. Okay, so that's the end of the lesson on ultrasound, and I hope you enjoyed the joke at the beginning. I thought it was hilarious. So what have we done today? We've looked at the two types of wave, longitudinal and transverse. We've looked at the wavelength, which is the distance between one wave and the next. We have looked at the amplitude, which is the height or the depth of the wave, or from a longitudinal wave, it's from the areas where it's crunched up to the areas where it's spread out. We've looked at how we can use ultrasound, which we need to remember is a frequency higher than 20,000 Hertz. Hertz is the measure of frequency of a wave. We've looked at how they are used in body scanning, so for full body scans or for prenatal scans, and how they're used to remove kidney stones. We've also looked at how they're used in industry to measure the depth of rocks. Anyway, I hope you've enjoyed this, and I will see you next time. Bye-bye.